Today we're seeking the second term in this sequence of very large integers such that, and I'll just use the letter A to indicate the missing integer that we're looking for. We're looking for an A such that this condition holds. And this is just another way of wording this in modular arithmetic. So we say mod, an abbreviation for modulo, mod 29. And this literally reads that 10 raised to the A power minus 19 is divisible by 29. Okay? So we're looking for the second such A, all right? Now let's move along. Now a good start is to note that 10 is congruent to negative 19. 10 minus a negative 19 is 29, which is a multiple of 29, of course. Now we seek an n. Now we're just going to try to find the first one first. All right, we're going to try to find the first n that takes care of this condition. And it's really easy but tedious. We just start elevating this to successive powers, like we square it. We multiply by 10 until we get where we want is basically what I'm trying to say. Okay, so 10 squared, 19 squared is 361. That leaves a remainder of 13. And again, I won't show you that work, but if you divide 29 into 61, you get a remainder of 13. Now, modular arithmetic says we can just multiply by 10. And so we multiply 10 times this 13 that you see. That's where this 130 comes from. And again, if you divide 29 into 130, you get a remainder of 14. So you see, we're looking for, let's see, what we need right here is we're looking for this. Just like I said a moment ago, we need 10 to the A to equal to 19 in modular arithmetic. Okay, so we're looking for a 19 to appear right here, right, folks? Looking for a 19 to appear. So again, carrying on all this, you just go on and on and on. It's tedious, but I wouldn't call it difficult, okay? And so finally, when we get to 15, we actually get the 19 that we're looking for. So again, no magic right here, folks. I know if you know a more elegant way to do this, but you can see I just plotted straight through by multiplying by 10 all the way down until we got 19, okay? So 15 will give us our first term. So right here, this would be our first term, okay? We're looking for number 2, though. Now, do we want to keep carrying on with all this, or are we going to try something a little more elegant? Now, there's something called the Euler Totient formula, and what it does, and I'll just write it down here and try to talk about it briefly. It's a pretty famous result in number theory, but what we know from it is that we get 10 to the 28th is congruent to 1. And I'll leave out the modulo 29. It's understood that it's modulo 29. Now, y'all, this is the Euler Totient function, and what it does, it counts the number of integers, positive integers less than the input argument that are relatively prime. Well, since 29 is a prime number, there's exactly 28 numbers. 1 through 28 are relatively prime to 29 just by definition, right? And so this is congruent to 1. So we can get the second term by just multiplying this part right here, this part only, by 10 to the 28th, because it's just 1 in modular arithmetic world. So right here, if you multiply this 10 to the 28th, which is 1, times this, you get 10 to the 48th. And it seems like, you know, you're doing something sort of illegal here. You don't have to multiply the entire congruence. You can multiply anything by 1, right, and get the object back, except this is just in modular arithmetic format. But the second term will be this, 10 to the 43 minus 19, which is congruent to 0. Again, the understood modulus is 29. Now, you may be asking that, well, how do you know this is the smallest such one? Well, it's a good point. But notice we didn't hit 1 in any of these. Any divisor of 28 is a possible what they call order. Okay, and so we notice that 10 squared is not 1. 10 to the 4th is another divisor of 28. You get 24 here. What's the next one? 10 to the 7th is a divisor of 28. 7 is a divisor of 28. We don't get 1. And finally, 14, the one right before the answer, is not 1. All right. So there's no smaller value than 28. 28 is what you would call the order of 10 modulo 29. Okay. Now, but the utility of that is just a quick multiply. And again, we didn't have to multiply the entire left-hand side. You can multiply any single term by 1 and maintain equality or congruence in this case. So the second term is this guy right here. Okay, thanks for viewing.